everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Rawan, who has just completed the course Linux Basics, and she'll be giving us a presentation of that. So first of all, we'll see her code base running on the real robot, and then we'll get to look at the simulation afterwards. And as always, we'll get to ask a couple of questions to actually get into the details about what she did and how she managed to do the project. So without further ado, I will now hand over the platform to her so she can begin her presentation. All right, whenever you're ready, Rawan.
Okay, thank you. Okay, thank you very much. I'm just running the scripts.
Okay.
I've opened the visualizer in another tab.
Okay.
And here I've opened the telope so I can, if something happens. Okay. So now, oh, it's not found. Okay, for some reason. Okay. The robot is stuck, so I'm gonna just move it a bit.
Okay.
Backwards because.
Oh, it's because you didn't start the Python script.
Yeah. No, I did, but
oh, you did. Oh, you have to wait for it to
like Python.
You have to wait for it to say ready first, then you can. Okay, it says it's ready. Okay.
Yeah, it started. The script it's starting here. Yeah, here it already got the readings from the lasers.
Okay.
And decided what direction is free, what direction is facing an obstacle, and then it decided to turn left. So now it's turning left. It's just like it's gonna take a long time to actually do something because the script is pretty basic. So the only way so it doesn't collide is to actually do it like very slowly. So I set the forward and the angular velocity to be very low, and I have also it checks the sensors every 0.2 seconds, so that's why seeing like a full thing will take a long time.
Okay, I see it's moving though.
Yeah, and the logic is running correctly. Now it's stopped. Now it's deciding to turn right because here there's an obstacle on the left.
Okay.
As you can see here too, yeah. And as we can see here, we're getting all the statistics for it. It's telling exactly how many how much distance is traveled, where is it heading, the northwest, and positions, orientations. So the statistics are also running well.
Mm-hmm.
Here we're also getting all the readings. This is the laser readings: front, right, left, right, right, left.
Okay.
It won't really do a lab, proper lab, because again the script is pretty simple and basic.
Mm-hmm.
So it will do, probably want to do a full lab, but I think it avoids obstacles pretty well for how simple it is.
Mm-hmm. Mm-hmm. Yep, true. We can move on to simulation, so we see how it does in simulation. So, but I guess
Yeah.
it is first the real test, right? The real robot.
Sorry?
I said I think it has passed the real test, right? Which means running on the real robot
I
without
think,
any issues.
yeah,
Yeah.
actually, I think it runs on the real robot better than the simulation because last few runs I've edited.
Oh,
Uh,
uh,
yeah, it collides.
what's
Yeah,
going on there?
yeah, because the steps, um, it doesn't work on all um the lab. Yeah,
Um,
it's detected. Yeah.
why do you think that is?
Okay, that's because um. Okay, let me just stop it. Okay. That's because the speed I've chosen
Mm-hmm.
and or the linear and the angular and the um the step I've chosen a step threshold, which is how many or how often does it read the sensors. And although I've set it pretty low, so it reads it frequently, but a lot of times it doesn't. Like if I run it again, this might not happen. It's pretty um like I can't really um
You cannot.
predict how it's gonna.
Okay, you cannot predict when it will happen and when it won't happen.
Yeah, sometimes it collides, sometimes it doesn't collide.
Okay.
It depends because it starts from a different place, and then the forward speed is pretty high, like because um I
So what
wanted
speed?
to run
So what speed
smoothly.
are you? What linear speed are you running at the moment?
I've used 0.15. I think that's like the lowest I could go lower, but for it to actually move. But
It'll be
sometimes
very
like
slow.
this happens, yeah, it would be like too slow, and then it would hit before the main loop would stop, and then we would check the sensors again. But
Oh, okay. All right. Very,
yeah,
very, very detailed observations there. I I do like that.
yeah, I've
Yeah,
run the code many times.
those are some
That's
of the
why.
subtleties actually you're supposed to be aware of. Okay, why does it happen, and why is it that it keeps stopping? Right. So you've actually mentioned the fact
Yeah.
that the
Because for me to actually choose the best, let's say, linear and angular speed, I've had to run it multiple times,
mm,
and this is the speed that I best got for it to actually move and have a movement and
mm,
not take a million year,
mm.
and for it to actually be slow enough. But again, sometimes it would just move forward faster than the step time, so it just happens sometimes.
All right, let's run the code in the simulation and see how it
Yeah,
behaves there. Okay.
but actually, I think it runs better on the real robot because um like the speeds kind of differ for the simulation and the real robot. Like it the real robot takes the speeds a bit faster, or the same speed runs on the simulation and slower than the real robot. So and the last runs I've kind of perfected it on the real robot, not the simulation.
Okay.
So
Okay.
I hope it works.
So
I just
is it an execution speed issue, or you're just saying the robot goes faster in the simulation or goes slower?
no, I've noticed that even in other projects in my other course I took, that it's just the real robot is faster than the simulation for the same speed.
um.
Like if at this time the robot would reach here and the re-robot would reach faster, like more
Okay,
distance.
that's okay. Okay, it would go further. Okay, I see what you mean.
Yeah.
Right. Okay. All
Yeah.
right.
It would still run fine, I think, but it's just gonna be slower even.
Okay.
So yeah.
All right. Let's see it. Since we still have got the time, and then we can get into
Yeah.
other things here.
Yeah, of course. Yeah. Oops.
You have to
Okay.
disconnect from the robot.
Oh, I need to disconnect the robot.
Yep.
Okay. 1 second. Okay. Okay. Can you still hear me?
Yes, I can.
Okay. It's just the website is lagging now. Okay.
Okay. All right.
Can I just do all of them in one shell, or do I need to open?
Yeah, you
Mm.
can. You can have them in one show. It's fine.
Okay.
Yeah, in multiple terminals, one process.
Just to be time efficient a bit. Hmm. Okay. Ready? Okay, it's still initializing the code.
All right.
Okay. For now, it's still working pretty fine.
Okay.
Yeah, it is turning.
Okay.
But it's gonna take so much
It's
longer
gonna
on
take.
the same thing.
I wanted
Yeah.
to see if it would avoid the
Yeah.
war in exactly the same way as it did in the previous one.
Yeah. It probably would probably also would end up colliding somewhere here, maybe.
Mm-hmm.
But as I as I hope it would
So
it would
is
would
it always a second corner thing or a third corner thing, or because why
it's
is it?
always after turning multiple times. It's always like it doesn't go straight. Okay, so it starts with a zigzag, and then after like the third or the fourth turn, big turn, yeah, it might end up colliding. I think it's because here when it starts from here,
Mm-hmm.
it's the same issue as the rear robot. Here you have a bigger step to take, so the forward there's more space um, to
Oh,
go forward, then you
okay.
would stop.
All right,
Here
I
it's
see.
like the distance is pretty short, So here I would have, like, overall, for it to work perfectly and not collide at all, I would have to decrease the forward speed more and decrease the step um, time more, which is just gonna make it
A lot
pretty slow.
slower.
It
Okay.
works, yeah,
Okay.
but it's gonna be very, very slow. It will take like 10 minutes to see a full lap,
Uh-huh.
I would think.
Yeah, that's good. And I think for what you have to work with, right? Because these are details that have got something to do with the node that's giving you the laser scan data, right? So
Yeah.
for what you have to do with the base script, these details are not really things that you should be playing around with, but for the parameters which you can control, I think
Mm.
that's quite okay to have it manage to avoid obstacles 2 or 3 4 times, right? But making
Yeah.
uh, slightly deeper alterations to how constantly it updates the angular velocities and the linear velocities based on what's in front of it, that's probably a little bit too
Mm.
much. So I think for now, let's leave it here and take us through your code base, right? So enough of the demonstrations. Let's see what you did, and you explain to us what you did and the logic behind.
Let me just see if you can see the code from my. Yeah, you can't. Okay.
Yeah. Okay. Yeah. Just move
That's
it a little bit more. Okay, that's fine. Yeah.
okay. Okay. So this is my main obstacle avoider script.
Mm-hmm.
Here we include the function libraries that we created later, which has uh, earlier, I mean, which has all the necessary functions I need for reading the lasers, for getting the velocities, and the basic functions I would need to interact with this specific robot.
Mm-hmm.
And then here is what's causing the issues, basically. Here I've set first the obstacle threshold, which is 0 0.3, so like 30 centimeters, I would say. And then the
So,
forward speed, the angular speed.
all right. So, what does the obstacle threshold do? What is it responsible for? Right. What does that parameter control?
It's responsible for the decision making, which is when it stops, it reads the the lasers, and then it would check, am I nearer than 30, am I further, and then it would decide if I should turn left, if I should turn right, or just keep moving forward.
Okay. Okay. So it's determines when will it consider to be close to an obstacle.
Yes,
Okay.
kind of. Yeah, it's a threshold that I compare uh, the distance I'm reading from the laser to know exactly kind of where am
Okay.
I.
Okay. All right.
Yeah. And then I have this forward speed and the angular speed, which I had to change so many times. And then this is also the step duration time. This is the step time I set. So every 0 0.2 seconds it would stop and then check the sensors again and then think again and take a decision again.
Mm-hmm.
I think the lowest I could have gone, if I went lower in these three values, I'm pretty sure it wouldn't have collided with any of the obstacles, because
Mm-hmm.
that's what happened initially when I started doing the code. But it would be just too slow that it doesn't run, basically.
Mm-hmm. Okay.
Here I'm just putting angular and linear versus zero, and then here we're starting the main loop. I would like to call it the sense, think, and act loop, which is first we are going to sense and getting all the readings from the scan, from the laser scans.
Mm-hmm.
We're just getting left, full, front left, front right, right. We're echo, and then we're printing them out. Here we're thinking, which is here is where we're using the obstacle threshold. So if the front left is bigger than the threshold, then here we have a boolean variable. If it's which returns one if the front left is free,
Mm-hmm.
and returns zero if there's an obstacle, and the same with the front, the same with the front right.
Mm-hmm. So you chose three sectors there. So your 180 degrees is split into 60, 60, 60 because I see you've got front. Okay, that's a front index. And then you'd
Mm.
have. Okay, I
Front
see.
left and and then a front right.
I see. I see. All right, let's go on.
Okay, and then here is the decision making. How does the robot act now? Which is basically if you'll check these variables I just made. So if let's say all blocked, so all of them are 0,
Mm-hmm.
then you're gonna have to turn left or turn right by checking the left and right,
Mm-hmm.
and all of them are the same. It's just the different scenarios that could happen. Uh, 0, 0, 1 or 0, 0, 0 or 0, 1, 0, like that.
Mm-hmm.
And then it decides if it should turn left or turn right. And then if all of them are free, then it just goes forward. And here you have the step duration, which is when it should stop and
All right. All right.
reconsiders again. Yeah.
All right. Okay. Now, okay. So I'm just gonna get into some questions before asking you about the base script, about your robot statistics base script, right?
Yeah.
Uh, so first of all, I want you to explain to me that if you had the opportunity of being able to control, or if you had the opportunity to allow your robot to have both angular velocity values and linear velocity values set at the same time, do you think it will be able to avoid the walls, right? So that means if there is no that stop act controller. I'm just trying to probe your line of
Well,
thought. Yeah.
yeah. Well, from the description of this project, that it is a pretty naive
Mm-hmm.
obstacle avoider.
Mm-hmm.
So, like, I don't think I could have found a way to both
Yeah.
move and read the sensors. That's why it stops,
Yeah. Yeah. Yeah.
reads the, then decides. If
Mm.
that's what you're asking about, I'm not sure.
No, it's fine. I know that is beyond your control. What I was asking was to just find out if you could see that far, or if you had that thought cross your mind to realize that, oh, actually it is doing the stop think act kind of thing, and because of that, every time it moves a certain distance, it has to stop and reconsider what to set those parameters to. So but it's fine, it's just for future purposes. I just wanted to find out if it crossed your mind a little bit. So um,
I
that's all
mean,
right.
it did, but I thought that it was out of scope for this
True,
project,
it
so I
is
didn't.
out of scope. Actually, it is out of
Yeah,
scope. It is out of scope. It's just for understanding
but that would
purposes,
be the
right?
logical thing
Yes.
to do because this is like, it's just not efficient to do
Mm-hmm.
this.
Mm-hmm.
But
Yeah.
again, I thought this is the scope of the project, so I didn't want to really do
Yeah.
more than it.
It's good. It's good. All right. So now, can you explain to me a little bit more about the robot statistics script? What does it do?
Yes,
And just run through how you implemented it in the next 2 minutes. Then we can wrap it up.
yes, of course. Here I've included the same library, the functions library, and then here is just um, what the project determined to write. And
Mm-hmm.
then here is setting the main loop, and this is a pretty basic loop, which is just we're getting um, the required parameters and readings from the robot function bash script, and
Mm-hmm.
then we're just printing them out. So first the distance, the direction, the XYZ, and then the orientation. All these, they are just they're all getter functions
Mm-hmm.
in the script. We're just getting them and then just writing out that value, and that is basically it. And here we just it stops for 0.5 seconds, and then it does again until we press Control C.
Okay. All right. Thank you very much, Rowan. So all right, everyone. This was Rowan's presentation. Congratulations to her. and I would like to encourage all those of you who would like to come and showcase their work to do so. And until next time, keep pushing your ROS learning.